Good afternoon, everyone, and welcome to the Geomatica Object Analyst webinar, the second of our webinars in the Geomatica 2017 webinar series. Geomatica 2017 represents one of the biggest software releases from PCI Geomatics in several years and provides improved analytical capability through the addition of Object Analyst for image segmentation, classification, and feature extraction. In this webinar, we'll take a deep dive and close look into this new object-based image analysis module now available. Object Analyst offers an intuitive workflow-based approach that makes it easy for non-experts and experts alike to more effectively use their remotely sensed imagery. Below are some of the topics that we'll be looking at today. I'm your host, David Pickney, Product Marketing Manager at PCI Geomatics. I've been working in the geomatics field for more than a decade with a background in geophysics and experience in sales, technical solutions, contract delivery, and product management. My responsibilities include product planning, competitive positioning, and aspects of launching new packages and updates. Our presenter today is Sean Malamed. Sean is a skilled technical solutions specialist at PCI Geomatics and an enthusiastic, experienced application developer. In addition to his work directly supporting sales and marketing opportunities, he is instrumental in assessing and communicating application needs, value, and technical details. Sean has been closely involved in the Object Analyst project and will be our presenter today. Just a reminder that all the lines will be muted during the presentation. During the course of the presentation, please type your questions into the questions panel, since we will be having a dedicated question and answer session following the presentations and demonstration. Please let us know if you have trouble hearing the audio or seeing the screen by sending us a chat message or raising your hand. You can ask a question at any time during the webinar, and we'll try to get to all of the questions at the end. I'd like a quick poll right now. And this is to ask, what object-based image analysis software do you typically use? We've got a few options there. Please select as many as are appropriate. And if you're using a package not listed there, we'd appreciate if you could just use the questions panel to tell us the name of that package. We'll keep this poll open for roughly 1 minute. We're about halfway done at this point. And we have about half of the votes compiled. Votes are continuing to come in. Seeing a clear majority for eCognition with strong and equal support for Esri and NV. Great, we'll keep this open for another 5 seconds. I'll count it down. 4, 3, 2, 1. Thank you to everyone who voted. I'll just put the results up on the screen there quickly, as described. And again, for the 19% of you who voted for or indicated that you're using another object-based image analysis package, please feel free to let us know what that package might be. Okay, let's continue with the presentation now. For those of you not familiar with PCI Geomatics, we are geospatial software experts who provide commercial and educational desktop packages, developer tools in the Geomatica Developer Edition, and enterprise solutions, including cloud, for image processing and analysis in the GXL, or Geoimaging Accelerator. We have a wide variety of offerings, and today we'll be looking at one aspect of what's new in our desktop suite, Geomatica 2017. In addition to Object Analyst, a newly developed INSAR module has been introduced, which permits the extraction of DEMs and measurement of ground deformation. An overview of all of these new features is available online now from our previous webinar, the first in the PCI Geomatica webinar series, on www.pcigeomatics and PCI TV. But now, let's get to Object Analyst. Object Analyst is a new package that provides image segmentation, classification, and feature extraction. This type of analysis is also known as geospatial object-based image analysis, or GeoBIA. In terms of the highlights of this package and some of the details that we'll get into during the demonstration, you'll see that Object Analyst is easy to learn and easy to use for object classification and segmentation for both experts and non-experts alike. This is in thanks, in part, to our wizard interface to guide you through each of the steps in the process. In addition, we have dynamic rule-based classification that produces highly accurate results, and this is suitable for a variety of image types as well as ancillary data like elevation values and image analysis and indices. We've developed a proprietary algorithm for quick and robust segmentation with spectral properties including min, max, mean, and standard deviation for each band, and geometric properties like compactness, elongation, circularity, and rectangularity. Support Vector Machine is our advanced machine learning classifier, while other highlights include generation of objects at different scales, automatic region growing, a simple click-to-merge interface, and the ability to effortlessly reshape, merge, and dissolve objects as needed. I'm going to pass the presentation now to Mr. Sean Malamed, who will start the demonstration of some of the features.
All right, thank you very much, Dave, for that wonderful introduction. So as Dave mentioned, I am a technical solutions specialist with PCI, and my job here today is to provide you with a live demonstration and to introduce two of our more exciting workflows within Object Analyst, which the first one is classification and the second one is specific feature extraction. Now, just to quickly provide an overview of the two, the main difference between, say, classification and feature extraction is that classification is the process or the operation of providing a number of different classes that you want to then assign to different objects in your image, such as buildings, trees, grass, field, etc., etc. So this is where every single area of your image is then classified within these different fields. Whereas feature extraction is the process of creating rules in order to extract a specific type of feature, such as buildings or only roads or only vegetation, so on and so forth. So I'm going to show how Object Analyst and our wizard can be used to effectively perform both of these different workflows. So we'll start off with classification, or as Dave kindly mentioned, GeoOBIA, or Object-Based Image Analysis. So this, as mentioned, is the process of first segmenting the imagery into discrete objects and then classifying each of these objects based on however many classes the user identifies as ideal. So in this quick example here, you can see we identified 7 different classes that were then used. Now, before we actually go into the workflow, I just want to quickly touch on the difference between our previous paradigm of classification, which was the per pixel, which still exists and are available and in some cases are a very capable classification method and may even be ideal in certain circumstances over object-based. But as you can see, the main difference between per pixel and object-based is that on a per pixel, we're classifying each individual pixel without caring about their neighbors, whereas in object-based, we first identify these discrete objects or group pixels together based on their similarities, and then classify those objects as groups. The nice thing about object-based is that the results or the output from this classification process or operation is vector polygons, meaning that they can be used for a variety of different set theory operations or GIS operations, such as change detection or quantitative analysis or mapping. So this slide is meant to just quickly, at a high level, identify or highlight the workflow and then as well as the input data preparation. So I want to first quickly start by mentioning the input data preparation. So one of the benefits of our Object Analyst wizard is that you can work with a number of different input layers as opposed to just simply RGB or near infrared or image channels. Whereas we can work with derivative layers such as digital surface models, or in actually the case of our demo coming up, normalized feature heights. So this is where we just get the heights of features such as buildings and trees and so on above local ground as opposed to above sea level. We also have NDVI or vegetation indices, a variety of different ones, or you can perform atmospheric correction as well, or a variety of different input layers or preparation steps can be performed. One of the nice things is that all of these operations or algorithms already exist within Geomatica, so you get to work within a single software environment, which really makes for a much more user-friendly experience. Now, when we actually look at Object Analyst, the classification workflow, we can see that there's a few key steps. So it starts off with segmenting your image, extracting the statistics, performing training site, supervised classification, and then refining your results, merging your polygons, and then performing an accuracy assessment. So that is the workflow that I'm going to walk you through actually right now. So I'm going to leave PowerPoint for a little bit, and let's just take a look. So I'm going to, this is an example of a result that we have previously performed with in terms of running this classification workflow. So you can see here that we have, if we choose our selection tool, you can see that we have road vector layers. So these are all this is all one single vector layer in terms of this road because they're all connected. And then we have different fields. So the nice thing is, once again, just to highlight the fact that we're working within a vector or providing a vector output. Okay, so we'll just close this for now and we'll actually get going. So we're going to work on or perform, we're going to run the same imagery, but we're just going to work on a subset for the purpose of processing time. So obviously, even something that takes a minute to process in a live demo can be a little bit too long. So this is the area that we're going to actually perform our analysis on. So you can see it's really just a subset of the image that I showed you earlier. And we have a variety of different features such as soil, pavement, buildings, trees, etc. So first, just wanted to identify the different input layers that we're going to be working with. So we have the RGB imagery. This is aerial imagery. So we do not have a near-infrared band, but we do have other indices that we can use from our algorithm librarian, such as a greenness index, which we've created. So if we view this in grayscale, you can see that if we toggle it on, the bright areas are where they're more green, and the darker areas are obviously where it's less green. Now, this isn't a perfect separation of vegetation from non-vegetation, but it will help as an input. Now, one that was actually another layer that's very useful for this is our normalized surface model. So once again, this is, if we just bring up our, load this in pseudo color, we can see that the terrain or ground terrain has all been normalized to an elevation value of 0, and building features are also been normalized so that we're providing the height above local ground as opposed to above mean sea level. Now this can be very useful, as you can imagine, in cases where we're trying to separate buildings from ground pavement where the spectral representation might be very similar. So we can use this height difference as well as with trees from grass in order to help separate certain kinds of features. So these are the input layers that we're going to be working from. All right, so to access our Object Analyst, you can go to our website, and we're going to provide a link later on to download the latest release of Geomatica, Geomatica 2017. After installing and using our trial license, you can then go to Analysis. So you open up this focus window, go to Analysis, Object Analyst, and this is going to bring up our Object Analyst wizard. Now, for those of you that are already Geomatica users, you might be familiar with our Ortho Engine product. So in a sort of a similar design, we provide the operations in a drop-down list, and it sort of guides you through the process. So you would start from the top, perform your segmentation, feature extraction, training sites, so on and so forth, and work your way down the list. Now, depending on which workflow you're doing, you might skip certain steps, but basically you work from top down. So we're going to start off with segmentation. So we're just going to simply choose the segmentation operation in this drop-down list. We're then going to load our source image layer, so we can go select, and we're going to choose our input image here. Then we can select all the layers that we want to base our segmentation on. So maybe you want to base it on everything with exception of the greenness index. So perhaps you want to base it on the RGB imagery plus the surface model. So that is an option you can choose. And then we have additional parameters here where we have scale, for example, and you can increase or decrease the scale now depending on what kinds of features you're trying to extract. So if detail and smaller features are important, then you want to use a smaller scale, such as for buildings or individual trees or so on and so forth. But if you want to extract just larger fields, perhaps these entire field areas as a single object, you would increase the scale, perhaps to a much larger value like 150. We also have additional parameters such as shape and compactness, and we can utilize those to help guide the segmentation to see if it should be more weighted towards spectral information or more weighted towards shape or compactness. And these are values generally between 1 and 0. So after you've done that, you can simply provide the output file or browse for an output file to save your segmentation layer in and then run the operation. Now, the segmentation operation takes a little bit longer than I'd like to actually run in this operation. So I am going to, we're going to skip that step. I've already previously run that step. So, and I'll just show you the segmentation layer that we load. So this is the segmentation result that would have resulted from running the step with actually the only thing I changed was I changed the scale to 35. So the next step that is necessary to run is the feature extraction. Now this should not be confused with the feature extraction for the workflow that I described earlier where you're trying to extract a specific type of object such as trees or vegetation or buildings or roads. This is actually collecting the statistics of the pixels that underlie a specific shape. So if we zoom in, now I'm not sure if anyone else is noticing, my screen seems to be flashing quite a bit. I'm just going to close and see if I can get rid of that effect. So I apologize about that. I'm just going to, don't know if that's an effect with my graphics card, perhaps. Anyway, oh, it's doing it again. So we'll just have to walk through that. So we'll just continue from where we left off. So I'm just going to load the segmentation layer. So the next step, as I mentioned, is you go to feature extraction, and you can choose your segmentation layer that you want to run with. Sorry, the input imagery rather. And this is where you can choose what statistics or which bands or channels you'd like to extract statistics from. And what this will do is it'll extract, for example, over here, the min, the max, the mean, the standard deviation, or whichever ones you choose for all of the pixels under each polygon based on the different channels that we select here. Now, as mentioned, I've already ran this, so we don't need to run that. But I'm just going to show you the result. And we can also do that about the geometrical properties of these different shapes here, such as this rectangularity, circularity, compactness, so on and so forth. Okay, so just want to show this quickly. I'm going to bring up my attributes table for this layer. So you can see I've already ran the feature extraction, so it's a very fast process. After you run the feature extraction, you're going to be provided, your attributes table will be provided and populated with these statistical results, which can then be used for the classification. So for example, if I look under this area here, we can see that we get the pixel value for, or we get the mean, red, green, blue, height, greenness, all this very useful information that can then be used for segmentation or for classification. Same thing with geometrical properties of that particular shape are also stored here, which can then be used in the classification operation. So after the feature extraction, if you want to do a supervised classification, you have to go to training site editing, which is the next step. Now, if you're running all these processes directly on here, these fields will be automatically populated for you. But because I've already previously ran them, I'm having to populate them myself. So we can just select that. And I'm just going to click Edit. So now when we go here, we enter into the next step, which is collecting and editing our training sites. So this is a finished product, what a finished product of training sites would look like. Obviously, I didn't want you to have to sit through while I manually collect these different training sites. But you can see here that it's actually quite simple. So you can add a new class by simply clicking on the Add Class button. It will create a new class here. You can then name it, assign it a color palette. Now in this case, I'm just going to remove this class. And we can see that we have, in this case, 5 different classes: building, grass, etc. Now what you should find interesting is we have 2 columns here. We have a training count column and an accuracy count column. So for the training count column, you can go in, so for example, for buildings, we can go into an area, to a building, and we're just going to select, say, these features, and I can go assign. I think this one's already been assigned. Let's find a new building. And essentially just by, you can select a variety of different polygons in here, and you can hold the control key to select a whole bunch at a particular time, if you wish. And then when you are done, you click the assign button. It'll then add them to either the accuracy count or training count, depending on which button you have toggled here. So because I already had a variety of them accessed, or a variety of them already collected, it wasn't adding them at that point. So we can do this for all of our different features. So for example, grass, we want to add a new field to grass, go assign, you can see it adds it, and then it colors it. And then for the accuracy one, once again, you can see that if I were to add that, it would then provide it with a sort of pattern fill. So once you've performed your training site collection, you can then close this window, and we can go down to our actual classification. So for this, we're going to select our vector layer. Once again, this will be automatically populated for you if you're running through the process from start to finish. And we're going to select all the different fields that we want our classifier to use to try to figure out which objects belong into different classes. So I'm using all my mean fields and then my geometric fields as well. So we can click OK to that. I'm going to name my output class, so I'll just call it my class. And then I'm just going to point to the training field site. We're going to choose our support vector machine and then run and add that to Canvas. So now, as you can see, it's a very fast operation. So if I remove this, you can see our classification has been performed. So now we have an option as to what we want to do next. So what I often like to do, and it's really up to you at this point, I would like to go in and I would like to perform an accuracy assessment at this stage to see how well my classification performed out of the box. So what I can do is I'm just going to go to accuracy assessment. My classification field is my class, the one I just created. And then for training, it's going to use both the training sites and the accuracy verification sites to see how well we assigned those classes to what we identified them as. So once we have this set, we can just simply go generate report, and then we have two very useful tabs here. We can look at an error confusion matrix to see how well certain of our verification classes were associated to the right class, and if not, which classes they were associated to. And we can also see an accuracy statistics report. So this is why I like to perform this early. So we can see that overall, my pavement, trees, grass, and buildings did a really good job. over 90%, but soil could be improved significantly as it's close to 60%. So what we can do now is I'm going to go back in, form a rule-based classification in order to remove or improve my soil class based on some rules. So I know from the confusion matrix and from, say, already viewing that some of my soil features or areas that I know are soil were misclassified as pavement. So I am going to quickly improve or change those as a batch. So I'm going to go into here, class field. I'm going to go to my class. For class filter, I'm going to go to pavement. This is the one that the class where something's been incorrectly classified into. So where we want to change it from pavement to something else. And then for new class, we want to change it to soil. So the other thing I want to do is I want to do something that's a little bit more advanced than what we currently have in our condition capabilities. So I'm going to show you that as well. And it's quite a nice feature. So you can actually go into the attributes table of here. We can go to our field calculator or compute option. I like to view the advanced mode. And I'm just going to create a new field that's a derivative of two other fields. So to identify and separate soil from concrete, we can actually just ratio the red and the blue bands together. Pavement will have a ratio closer to 1 because they're similar spectral information across the board, whereas soil will have a ratio value that's usually greater than 1, fair bit, and it's easy to separate. So to do that, I'm just going to go mean red, then put the division sign there, and then after that, just go mean blue. And I'm going to change this to just call it soil, maybe soil metric. I'm going to change the field type to a double and run this process. So now we have our new attribute here, which I'm just going to close. And we can now go into specify condition, pick range, and we have this wonderful WYSIWYG viewer that will allow me to, I'll just bring it up here, allow me to quickly change those features. So I'm going to change my class field to my class filter to pavement, the range field to the soil metric that I just created. So you can see that as it's close to 1, we're getting a lot of the road. But if I increase this and then increase this, and as I said, it's a WYSIWYG viewer, so you can look at your features to make sure that you're actually removing the features you want. So maybe we need to increase this a little bit more. I'll just increase it a little too high. And you can play with that, trying to find the right value. And once you have that, so we can see a lot of our. So I'm actually just going to decrease it a bit more. And so a lot of these fields areas are being reclassified and identified here, highlighted. So I can simply click OK once I find the perfect one, and then click OK. And then once I have that, my condition is set here. And I can simply go add and run. And now you can see these have been reclassified as soil. And at this point, I can go back into my accuracy assessment. And I'm just going to do another accuracy assessment on the same class, provide the training, regenerate the report. And I can see that I've significantly improved my soil accuracy now as it's closer to 90%. And you can continue to do these kinds of things to really simplify your process. So the last step that I'm going to want to do now that I'm actually quite happy with my overall classification is I'm going to go to reform shapes. So I don't want all these individual little objects. I want them to be sort of merged together. So shapes that are of the same class that are budding one another will now be merged into one single object or entity. So it's quite simple. We just go to class filter here. I'm going to go down to my class. I'm going to browse for an output. Just call it result. Go save. I can then go to new layer. I can change the name if I want. and then I'm going to click Run. So now it's going to run our dissolving process, and if I unselect here, you can see that we have our final classification. And we can then select these individual entities. All right, so that is essentially our Object Analyst wizard for performing a supervised classification. So we'll close this down for now and continue back to our PowerPoint. So with that, what I just showed you in your mind now, and to see the simplicity of the workflow and also the power and the flexibility of the workflow, what's also important is that we are also performing real-world accuracy assessment tests. So this test in particular, which will be published as a white paper in the near future, was performed in South Africa by one of our senior scientists, Wolfgang Luke, and basically he worked with Landsat 7 ETM Plus imagery and basically worked on 3 different areas in South Africa, used the our Object Analyst wizard with the support vector machine algorithm, and was able to achieve incredibly high accuracy as compared to ground proofing. But what's also interesting about the test that he did was he also used the signatures that were generated by an image which is identified as AOI, applied those signatures directly to radiometrically normalized imagery, so a different image, which is identified by EXT, and then just ran the classification on those. And what he was able to identify was that he got a very, very high classification. Now, what this means is there's potential future implications for having a workflow for a highly automated workflow for reusing signatures, which is quite exciting. So the conclusion from this test was that the Object Analyst classification accuracy using support vector machine was about 95% accurate in most cases as compared to the ground proofing and training sites. And as mentioned, it was quite successful in areas where we didn't have training sites, where we just applied the signatures. And what was quite, as I said, the exciting aspect about that is the potential future implications for automation. So I also like to mention one of the challenges is segmenting as well large imagery. So due to the memory size limitations, we do have some very useful workflows that you can apply if you're working on large images that would exceed the memory limit of your machine. So one option, which is the easiest option, is to just simply downsample your imagery. So this is applicable when you're working with when full detail of an image is not required, or you're trying to extract larger objects like those big fields instead of individual trees or so on and so forth. Another option, which is an area that we put a lot of effort into sort of identifying, is when you do require the full resolution and detail does matter and you're trying to extract those small features. So we've developed a workflow for doing tile-based segmentation. So first tiling your image around natural boundaries to minimize the tiling effect between or the boundary effect between individual tiles. So those artifacts that would often show up between tiles, we're able to significantly minimize those by first identifying natural boundaries. And we have a workflow for that. Actually, it's now available as the tutorial on our support.pcigeomatics.com website to show you how you can go about doing that. Okay, so now I'd like to show you another but very quick workflow. So this one's much quicker. And this just shows a methodology for using our Object Analyst in order to perform feature extraction. Now, not to be confused with the feature extraction operation in the actual wizard, but this is the workflow or the process of extracting specific types of objects or features such as buildings or roads or vegetation. So I'm going to show you that workflow. So right now what you should be seeing on screen is an overview of the primary steps involved. So same thing, your input data preparation. The more useful input layers you provide, the better your feature extraction will be. And then the actual feature extraction operation includes segmentation, extracting the statistics. Then you skip the training and the classification part and jump right to creating the rules, and then finally merging your polygons. And then this can be used for very useful applications such as change detection. So we actually did a process not too long ago where we did feature extraction of buildings, and then from 2 different dates, and then did an intersection analysis between those objects to identify where we have new construction, and this was used for illegal building monitoring. So I'm going to show you just a quick feature extraction demo right now. Okay, so we'll work with the same input imagery. And in this one, we're just going to go right to Object Analyst. So you should all remember that we have normalized DSM or heights and a greenness value. So I'm going to go right into the segmentation. And this time, because I'm not doing training site, I can actually run the segmentation for you live. So we're just going to select our input imagery. We're going to select all the layers except for greenness. Click OK. And browse for an output. So we'll just call this seg live. Call this, you can just keep this as is. And we'll run the process. So this is to show you that it's quite a fast process. So it'll take a few seconds to complete, about maybe 10 to 15 more seconds.
And Sean, while we're waiting, I would just remind our audience that if they do have questions, please keep them coming in. We've got about 10 questions so far, and we'll try to get to all of them at the end of the presentation.
Okay, now that the image segmentation is finalizing, and we'll have our result momentarily. There we can see. So now we can go down to the next process. We're going to feature extraction. So I'm actually going to run it. So this time we can, same thing, you want to create your names so that you can identify them easily later on. And then so we have heights, and the last one was greenness. So we're going to select, in this case, I'm going to select all of them because we want to extract the statistics from all of our channels. And go OK, but we just want the mean. This time I'll do the standard deviation. I'm going to do all of our geometrical ones just for fun, even though I really am only going to work from the mean. Okay, so then I can just add and run that. Now, as you can see, very quick. So the statistics are now added. And we're going to skip training sites classification, jump right down to rule-based classification. And the first one that we're going to do is we're going to perform or extract vegetation. So I'm going to create a new field, and I'm going to call it veg. And for my class filter, I'm going to do the node data, which is that's our node data value. And then for the new class, I'm going to put it as vegetation. Okay, so now I'm going to go specify condition and go right to pick range. And for this one, I'm going to keep as none selected. And then for range field, I'm going to go down to our mean greenness index. And then I can now just increase this all the way to the maximum green. And then now we're going to play with this one to identify what we want to identify as vegetation. And let's just say that is where we want to set the limit. So you can play with it to figure out exactly what you want as your limit. And then just click OK. So it's now going to be set there. And we can click Add and Run. So now we have that. And then I can go down to our reform shapes. And we're just going to choose the veg. Create a new output here called vegetation. 2. Save. Apply this, run. So it's now dissolving these objects. And uncheck that, and I'll just give this a more appropriate color. So let's change it down here. And just like that, we've extracted our vegetation field. Now we can actually do the same thing for roads. So it's a same thing. I'm going to use that somewhere a condition actually. So I'm going to do a little bit more complicated. So we're just going to go back into rule base. So you don't need to settle for just one. So we're going to create a new one. Just call this roads. And class filter no data. A new class will just say roads again. Now this time I'm going to go back into our attributes table. And I have a special index that I've created. It's essentially sort of a heuristic. So this is identifies concrete well. So I'm just going to copy that and go to record, or field rather, compute. So you already saw this previously. I'm just going to paste my condition in there as is. And just make sure that all my, let's change that to mean heights, make sure everything's spelled correctly. Change that to mean red. And then same thing. Okay, so just call this roads or road metric. Change this to a double, and we'll run this process. So we now have our new field, and we can use that in order to extract. Okay, so we're just going to specify condition, pick range. So, sorry, 2 seconds. So sometimes you need to toggle or try different values or see what's the right value. So I'm just going to, this time we don't want to make it the maximum. We know that from what I mentioned previously that, should keep this as none selected. So what we want to do is we want to keep this probably around 1. So maybe I have an upper limit around, maybe like around 1.2. Okay, and then we can have a lower limit, and we'll set it to 0.93. So as you can see, as you can probably imagine, I've previously been playing with this to figure out a good threshold here. Okay, so I can just click OK, and then we're going to run that, and then that. Go to reform shapes, choose our roads, browse, put a new one here. And now we have our roads layer. Okay, so that is essentially how you can now use Object Analyst for specific feature extraction as a feature extraction workflow. So as mentioned, you can then use this for performing object-based change detection. So in this case, we were looking for new structures, new buildings between different dates. So we can do that to get a much more reliable result. So with that, I'm going to hand it back over to David Pickney, and he can conduct our next poll and conclude this webinar.
Right, okay, thanks very much, Sean. Okay, so I'm going to bring up the second question of the day. We have 3 today, so one more after this. So here we're interested in it's what's most important to you in a object-based image analysis program software. So these are the things that we could be focusing on in future versions. Maybe it's speed of the actual segmentation algorithm, perhaps the ability to handle larger images. Maybe it's more types and more advanced types of segmentation algorithms themselves. We've got support vector machine and maximum likelihood classifier. Maybe there are other methods you'd like to see there as well, although we've optimized for those based on accuracy. Maybe it's more classification methods and rule-based classification rules as well. Again, if there's something else that you feel is important, feel free to specify that in the question window as well. We've got about half of the votes in so far. The poll's been running for about a minute, so I'm going to count it down. You get your votes in the next few seconds. 5, 4, 3, 2, 1. Great. Okay, so I'll bring that up. The results there. Looks like the classification methods and the segmentation. Actually, everything's pretty easy. Speed doesn't seem to be the primary driver for the segmentation tools, although we of course want to have a fast and easy workflow. But it looks like flexibility in terms of project size and project capability is quite important as well. Great. Okay, sorry, I've got Sean's slides here. I'll just bring up. Okay. So just as a review of the work that we've seen today, just want to highlight again the capabilities of Geomatica Object Analyst. First and foremost, that we want this package to be easy to learn and easy to use. We've received a couple of comments in the questions already to that effect, saying that yes, especially with the complexity of the interface and what's available, it looks like it's pretty straightforward, and it is. We hope this saves time and provides all the flexibility you need for your projects. In addition, the advanced proprietary segmentation algorithm that we've developed is new. It's fast, it's powerful, it updates technology that has been around for over 15 years at this point. So we've taken a fresh look at that, provided very accurate results while taking advantage of modern computing methods as well as the accuracy of the support vector machine classifier. And finally, the object reshaping tools with the merge, dissolve, and geometry changes, again, aiming to save time, make low effort, and have the entire system easy to use. Additional resources related to Object Analyst and everything you've seen today are available online at pcigeomatics.com and at support.pcigeomatics.com, where we have new tutorials and a user guide now available for both feature extraction, specific suggestions for segmenting large images, and then overall detailed classification workflow, which we'll be posting today. So when you receive your update to this video saying that the recording is available, we'll also have those tutorials available online. Here's a quick peek at the support page. You can see besides the tutorials, there are a number of other resources available. Past webinars, additional training guides, case studies, and frequently asked questions. If you look at the tutorials section, you'll see a topic called Focus, and under this Focus interface, we have the Object Analyst tutorials. Or, using our Help Center, you can search for Object Analyst directly in our knowledge base and see the tutorials and resources we've already posted, as well as recommendations or suggestions that we've received from within the community. Okay, now it brings us to the final poll of the day, and then we'll get to our question and answer period. So based on what you've seen today, what's your interest level in Object Analyst? Maybe you're very keen and would like more information from PCI. Perhaps you're interested and we'll go to the web page to find out more, to pcigeomatics.com and support.pcigeomatics.com. Perhaps the software you're using suits your needs perfectly well. So be it, that's great, but I can say this is just the first version of our object-based image analysis, and we expect it to be faster, more accurate, and more capable in the future as well. Or maybe you're just curious what this is about, but don't really need this type of capability. So we've got about half of the votes in at this point. I'll give it again a few more seconds. When we get to the 1 minute mark, we'll continue to the question and answer period. Now, very excited and pleased today, during our question and answer period, we have our lead developer, Dr. Masroor Hussain, available on the line, and we can get him online in just a moment. He'll be available to provide some insight or perhaps answer a question or two. He, of course, is very interested in learning your thoughts on Object Analyst, as are we all. Okay, I'm going to close the poll now. Looks like everyone is interested. I won't share these results. I think it's safe to say that we have a high level of interest, as evident by your very attendance, and we thank you for that. So, as we mentioned at the beginning, this is the second of 3 webinars in the Geomatica 2017 webinar series. Our Geomatica 2017 overview, including Object Analyst, INSAR, and other features and additions in Geomatica, is already available online. And in 2 weeks' time, we'll be having a dedicated interferometric SAR webinar where we go into the same level of depth and detail on that new package. We hope to see you there. In the meantime, you can download Geomatica 2017's fully functional trial at www.getgeomatica.com. And there's demo data there available, so you can try out all of these, all the things you saw today at the Object Analyst demonstration, and many more. Okay, so now let's see if we'll get Sean back online.
Unmuted. Muted.
We've got Masroor as well. Masroor, do we have you on the line with the audio?
Hi, David. Thank you. Can you hear me?
Yes, I can hear you. Thank you very much.
Yeah, thank you. That was pretty interesting. As a lot of things are explained here. So yeah, you're welcome for any questions now.
Certainly. So I'll go through a few of the questions that we've already received.
Yes.
And there's some I was able to provide answers for already. So those are the easier ones. Perhaps I'll... and this is a question about the use of a digital terrain model versus a digital surface model.
Yes.
And I know we do have the tools within the software to do any type of filtering, both automatic
Yes.
and manual, to remove the elevations, but that these can be quite useful when we're doing the classification, for instance, to distinguish between objects that would otherwise look the same.
Yes.
The example we had was perhaps on a building rooftop. It could be gravel or asphalt, and a rectangular shape looks very much like a parking lot. But the difference in elevation helps to distinguish those as 2 separate classes.
Yes.
Okay, so I think that was an easy one.
So,
I'm glad.
I think what was going to happen when you're talking about doing those classification and defining the rule, there is no limitation. The thing is, like, you can extract a lot of features that are available within the focus and within the Geomatica and do that computation. So one thing I would like my audience to know that there is this is an ongoing development, and we are trying to include a lot of useful features directly within the Object Analyst interface, so you don't need to go to different places to do the feature calculation, and most of the things are going to be readily available within the same interface, and you will be able to do a lot of things on fly. So currently we have a ton of advanced algorithm within Geomatica, which you can use to extract different features. You can do your mathematics there, you can do band calculations, and you can add them as part of as an attribute to the segments table. And because we are leveraging the core technology within Geomatica and we can exploit all the features associated to the vector segments, yes, you can use them within Object Analyst to define your own rule. So that would be pretty straightforward.
Okay, great. And on that note about what's included with Geomatica, we had a couple of questions about packaging. I can certainly answer those. I can say that Object Analyst is an add-on to Geomatica 2017, so you do need either the core or the prime license to which you can add Object Analyst. That is for commercial customers. For educational customers, and that includes student licenses in North America, Object Analyst is included already in the Geomatica Education Suite without additional cost. So anyone who is under support agreement with PCI for an educational license, or for anyone new purchasing a new license, you will receive Object Analyst with your education license. And of course, as I mentioned, everyone else can download the trial version. It's a fully functional trial version for 30 days and be able to test all this functionality as well. Okay, I had a question here about perhaps this is a request for a future capability, I'm not sure. Can we have training sites selected in a shapefile and import them? So can we import? We had a couple of questions looking at that specifically.
Yeah, I was looking at that question, and I think it's right now within the Object Analyst framework that might not be straightforward. There is a workaround which I am discussing internally, and probably we would publish some short tutorial pretty soon. However, the automated methodology to incorporate training sites, whether it's in the shapefile format, whether it's in the geodatabase format, whether it's in the raster database format, either it's a polygon, it's a point, we are actively developing and testing those things. So those capabilities within the object-based analyst framework would be available pretty soon. For now, there is a way around within Geomatica. We don't have to use any other software. We can still do it within Geomatica, and I'm looking to develop that simple workflow, and hopefully you're going to find it pretty soon.
Okay, fantastic. I think we've got time for one final question. Something we didn't look at specifically, but can you manually change an object from one class to another after it's been collected?
The easiest way at this moment is to define rule per shape base. You can do it quickly, and you can also take advantage of the existing technology within Geomatica. You can open the attribute table and you can select your feature you want to change the class, and you can manually type in. However, this requirement was well understood and is in our working package. So we are also looking into develop a very user-friendly and interactive, easy to apply way of changing class manually just for those selected polygons. So yes, that easier tool is something that's going to be part of the newer development, which we are actively doing. But meanwhile, if someone is interested in changing the class of a particular polygon or any segment, what they can do is they can open the attribute table and they can select that polygon, go into that attribute, that class field column, and then they can manually type in. So in this way, they can do it.
Okay, so yeah, and as we saw with Sean as well, some of the soil class was miscalculated as pavement, and he was able to reclassify by selecting some of those, although it was by using the rule base.
Yes, because the thing is that the way we had kind of tied it to the rule, because we are trying to establish this workflow. So the thing is, like, if you think a logical way of doing the classification, you probably run your classification using the machine learning algorithm, and some of the results you are not happy, and then you define rule on top of that one, which will improve the classification results. So logically, those things are operations. And if you see the way the whole object-based image analysis or the object analyst has been designed, it's an operation-driven approach. So yes, there are certain components where we are allowing the manual interaction, and one of those requirement identification was to develop something to interactively select polygons and manually change the classes. So yes, you can expect that thing to be part of our future release, but meanwhile you can do it within Geomatica.
Fantastic. Okay, thank you very much. So that brings us to 3 o'clock, to the conclusion of our webinar. I would like to thank Dr. Masroor Hussain, the lead scientist on the project, and as well as Sean Malamed, our presenter today, and certainly all of you as well. Thank you very much for your attendance today on behalf of PCI Geomatics and everyone involved for your attendance, and we hope to see you in 2 weeks' time at our Geomatica INSAR presentation. Thank you very much, and have a good afternoon.